like where we are right now. We're making some of our Schiit. I could do it way faster than that with my bare hands. This is Greg Liu. He's over here at Jaxx Manufacturing. They make our boards. And I'm just going to let him take it from here and explain what this awesome thing is. I wonder if this will fit in my garage. How much is it?
The machine is about 300 grand.
300 grand?
Yeah. And
do they take payments?
Yeah, barely. Sometimes. A lot of coupons. So.
Right on.
But
cool.
yeah, the split is basically the base machine is about 150K, and then all the feeders that go with it and tooling is about another 150K.
Yeah.
So out the door, you're looking at about 300. Okay. All right.
Cool. All right. Let's get this party started.
Yeah. So we'll start from the front end, and we'll work our way through it.
Copy that.
So we have the privilege of being able to build the Schiit boards from the very beginning. We started doing hand placed prototypes, and then have now been working into these thousands of pieces a week that you guys are producing for all your different products. The process starts out with your board, which we receive, and we get some Gerber data, which we then send to a stencil house. And the stencil house will make a stainless steel stencil, which will look like this. And this is a laser cut stainless steel stencil where they take the Gerber data, they cut out the apertures that match up to the board that is being built, and then this goes into a screen printer machine, which then screens on the solder paste. So although this is just a sample, it's not the board that we're running right now, but we're running, I think, the full or the Modi 3, and we're getting ready to run the Ragnarok. But the bottom line is we'll put a stencil that matches the board that we're going to build into this screen printer. The screen printer has a large stainless steel squeegee that drags across the surface of the stainless steel stencil, and it leaves a solder deposition layer for the components to adhere to, during the pick and place process. Now we've got, you can kind of see the inside of the machine. They're changing out the components. Right now, one of the feeders just went dry. This bank, all these banks that you see here are components.
It's every part that goes on this board?
Yep, every part that goes on this board, on this side and the back. And basically, there's a little piece of tape, clear tape that gets peeled back by the feeders, and it exposes a tiny little cavity there. And then the nozzles on this machine will just come over and pick up each of these components, place them on the board, and then they'll pass through the system. Now this place is about 20,000 parts per hour.
So I was always wondering, you got these little arms.
Yep.
That come and
correct. Yep.
Now are they adhering the parts to the board at all, or are they literally just sitting on there?
So what happens is, so these are the heads right here, and all these heads fire. They come over here. Part of the arm pushes down this lever, which opens the window for the part. And then one of these little nozzles has a little tiny vacuum, and it goes down and it sucks the part and holds it, and then it releases the part. So it just vacuum on, vacuum off, vacuum on, vacuum off. And that's what that video you saw going back and forth was. It was doing.
Right. And it just sits there? It sits
on top. It's basically stuck on there because the screen printer, when it leaves the solder paste, it leaves solder paste on the board and all the apertures that were on the stainless steel stencil.
Solder paste.
So the solder paste is essentially the metal glue that hasn't reflowed yet. That's just sitting on there. And so the component, when it gets inserted on top of it, is sitting on pillows of solder. Solder paste, I should say. Right?
Solder paste. I want some of that.
Yeah, it's really good on ice cream.
All right.
Yeah. Then it'll just go through a pass-through process where the operator will place anything that came in bulk or for whatever reason it needs to be handled manually. Also gives them something to do between board runs because the board takes maybe 2 minutes each to run, and so otherwise pretty bored, no pun intended.
Yeah.
Then it goes through one of these things, which is essentially a glorified pizza oven. What this does is it slowly brings up the temperature of the components, the board, and the paste up to a temperature that causes the paste to reflow. And it becomes molten metal. And then it goes into a cool down zone. And it does this all to a particular profile so that the components don't suffer any thermal shock damage that can happen if you heat up something too fast or you cool it down too quickly. Yeah. And then it comes out the back of the oven, and now all the components that were placed on the machine are soldered onto the board. Obviously, the helps versus the manual process of doing it. It's just completely automated.
The top stuff.
So there's your board with the SMD complete level, and then the inspector basically just double checks everything, looks for any issues or trends that might be happening in order to be able to feed back to this system what's going on in the manufacturing process. It's kind of a secondary catch-all just to be sure that the process isn't deviating. In some cases, there are really components that need to be hand soldered specifically.
Oh, that looks like pull-up.
Yeah, but it's the busy board. Now all of these machines that you see laid out here before you are essentially parallel lines, all doing the same sort of thing, doing different products, etc.
So what are we running on the ones over there?
On the back machine, I think you're running your 4. Yeah.
Cool.
So, after the surface mount process is complete, then it has to go into a wave, well, most of the boards end up going into some sort of wave solder situation. So, they'll pass from here, and they'll go into the board prep and mask area. There's also mechanical procedures that need to be done. Schiit uses a lot of standoffs because they mount them into chassis, etc. So there's pre-prep processes of mounting standoffs.
This
manually.
is the standoff guy?
Yep.
So you're the one?
Yep, he's the one. He's one of the ones that are many of one. Yeah, he's the one for right now. But he's mostly 3 people under that. And then there's the masking process. And so this is a board prep process. They put on a rubberized mask, and what happens is, so he's got the standoffs on, and if we were to flow that board in the wave solder machine, those standoffs, being metal or having iron in them, solder would automatically adhere to it.
Right.
And we don't want that happening on the standoffs on certain things. So certain holes on the board, certain parts on the board, we put mask over so that it can go through the wave solder process and it won't take on the solder.
Is it like a thermal paste?
It's more like a rubber. It's a liquid rubber, and it takes about 10 to 15 minutes to air dry. And at that point, it's able to take up to, I don't know how many degrees, but enough to be able to survive the wave solder process and protect the parts that don't need solder. So that's a prep situation. After prep, they'll go into a stuff situation. There are some boards that are in limbo. They've been mechanically, the standoffs have been put on them. They've been masked. Then they've been stuffed to a particular level of completion. Looks like they just have to do some other connectors and switches, which in this particular process is going to have to be hand soldered because they're not hermetically sealed. They get wet, they're gonna fail.
So those of you guys in the UK that were waiting for Manny,
they're there.
Here they are.
All right, so the next process after they go through the inspection is they're going to go through the wave solder process, which is essentially another process of soldering components to a board, the same way we just saw the surface mount process get done. But in this case, the parts are going, it's very clever, they call the one surface mount because the parts are mounted on the surface. This one's called through hole because the parts are inserted through holes in the board. Yeah. So you can see how advanced they are in the naming.
So this is how you wave solder the through hole.
So here, if you can look on that screen, This is one of the wave soldering devices. This particular process or machine is called the selective solder system. And by selective solder, it's just as the name again would imply, it selectively solders points on the board as opposed to wave solder, which is a different process, which we also do. Now, the wave solder process, which is that back machine over there, instead of doing little pinpricks of solder on the parts underneath the board, in some cases we have some of your larger boards, like the Yo 9 main, where the time to solder on the selective solder machine is slower than the time to solder on the wave solder machine. And there's a few different parts that get involved in making the decision on which machine to go. One is time, the other is components. If the board is double-sided, you don't want to you can't wave solder over the wave solder machine because the components would just fall off the bottom. Right. Unless you epoxy the parts down, which we typically don't do just because there's thermal issues that can happen by wave soldering the parts as well. So for the sake of ease, if the board has a lot of parts on the bottom, we'll typically selective solder it. If it is not populated on the bottom or has very few parts, then we can wave solder it. And again, it's just for time. Wave solder, it passes over a conveyor, goes through a thermal chamber that brings it up to temperature, same way the reflow oven works. Then it'll go over a 18-inch wave of solder, a molten wave of solder. And then all the exposed metal on the bottom side of the board, it'll wet the components and they'll be soldered in place.
So it does it on the bottom.
Yep, so it literally rides a wave of solder.
It does it on the bottom. Now there's probably, you know, the metal legs are sticking out still, or do they trim them off for that?
Yep, so the metal legs have already been prepped to a certain length. They're sticking out the bottom of the board. The board goes on this stainless steel finger conveyor system.
Ooh, it's warm in here. Oh, look at that. A molten solder pool.
So that's a big 1,200 pounds of molten solder. And this creates this wave right here. And this conveyor will open up to the different widths of the board. But basically you insert the board on these fingers. It'll go through from the front end, you insert the board, it goes through a fluxing process. It has a bubble fluxer that the board just skims the top of. And then it has flux on the bottom, which is the wetting agent, so that the solder will really wet nicely to the board and to the parts, making a nice solder joint. And then it goes through an infrared thermal chamber, which brings it up to temperature slowly, so it doesn't suffer the thermal shock when it rides over this solder wave. And then it literally just skims the top of that wave, and when it comes out the back, all the parts are soldered on to the board. It looks like a T1000.
Yeah, exactly. Jaxx Manufacturing becomes Cyberdyne Systems and makes the T1000 right here.
Yeah, that's a good idea. We're working on that stuff in the back.
That stuff's in the back. That's the aliens and Bigfoot stuff you can't show me though, right?
That's right. So just as the two methods of soldering, it's kind of like this system is a carpet bombing system where you just take on a whole lot of solder at once. This is like smart bomb. You're like literally hitting just little points on the board, and you're done. So, turn that off. All right. So that's the wave solder process.
Wow.
And then, depending on the mix, in this particular case, that's an organic solder. They're using an organic flux, and the flux needs to be washed off. So this is a wash system. So this might seem a little odd to have water going on in your electronics.
Only if it's dry when you turn it on.
Well, not only that, but the water has to be at a purity level that there is no conductivity. So literally, these wash systems, if you put your TV in it, you could like watch TV while it's underwater because the water has been completely deionized, completely stripped of any particles that carry a charge.
So the water is not conductive anymore?
Completely non-conductive. Yeah.
No shit.
Inside this machine. So what it is it's fed by this other larger machine, which is what they call a closed loop wash system. And the closed loop wash is uses different types of resins to strip out the charges in the water. And makes it a purity level that is
drinkable.
This particular, well, it tastes horrible because it completely has no mineral, it has nothing in it at all. No conductivity, no salts, nothing.
Oh man.
So yeah, you could drink it, but you wouldn't want it. Wouldn't hurt you in any way, but just not good. But just for reference, these are floating at around 16 mega ohms resistance. The standard, the limit for electronics, I shouldn't say the limit, the lowest level typically is around 50K, right? So, you know, let's say 50K in memory.
So the water has 50K of resistance?
Is the minimum acceptable rate for electronics.
Gotcha.
Most houses use between 1 mega ohm and 3 mega ohms. We actually have ours at 6 mega ohm just because we like to be, it's kind of like on Spinal Tap, you know, it can go to 11. So yeah, ours goes to 18, so we're like, It doesn't really need to be that high, but it's just the cleaner it is, the better it is. Basically, you have, so you could actually take a wet board out and essentially plug it in and it would still be fine.
Yeah, I always wondered about the wash. I thought it was just a special chemical or something.
No, you can use chemicals. There are other ways of doing this, but deionized washes have been here for 30 years, and it just continues to get better. And because it's really just water, then you don't have different chemicals. There's what they call saponifiers and surfactants that you can add to make it cleaner. But if your water's this clean, there's really no need to. In fact, the water's so clean. The reality is this water's so clean that if there is water still sitting on the board, you know, we have a air gun that we can blow off that water. But theoretically, well, actually, from a physics standpoint, the water's so clean that it will start pulling atoms out of the air just because it's so starved, because it has nothing in it.
Wow.
It'll actually extract. So that's just a little physics there.
So it's pure dihydrogen oxide.
Deionized water, 100% clean. Well, updating this part of the manufacturing is really just a lot of the different prep work that goes prior to the actual stuffing assembly. There's mechanical parts that are done. There's component prep. You can see this machine is actually cutting the leads of the components that get stuffed prior to wave solder. So it puts it at the proper lead length, again, for what they call the IPC 610 specifications, which is the electronics industry manufacturing specs. So there's also a spec about lead lengths, and about cleanliness, and about tilt, etc. And so these are all parts that go into the process to make those boards just right. Some mechanical stuff. And then we have more stuff. We just have more manufacturing. So in this particular case, I think we're doing the Modi 3s, and we're programming them. And this is basically the final end of whatever there is we have to get done for the customer specs. Some customers have us build things up 100%, right into boxes, serialized with manuals and the whole thing. Other ones have all sorts of special proprietary methods that they like to keep under their own roof, or they need to for whatever reason. So we'll just build to whatever level of completeness that is dictated by the customer.
So this is the last stop, or?
This is essentially, yes, essentially the last stop. This is the final assembly, and actually this is the last stop for production. There is a final inspection that happens in the very back corner over there, where they do a full microscope inspection of all the SMD, they do a full lens inspection of all the through hole, and then that passes back on to test, and if anything isn't working at some point, then it was something.
All right.
So but typically we have above a 98, 99% pass rate. A lot of parts are, again, they're not hermetically sealed, or they're just sensitive to even exposure of even pure water. So they don't get they don't go through the wash process. They have to be hand installed after the practice of manufacturing, and then they'll go into these lovely boxes where our van will head out and drop them off to.
And this is more mayonnaise.
Yep, so there's 250 manis there, and then there's 100 Jotunheim mains. So we got
He's taking it to the truck.
300. Yep. Yeah, actually, that's exactly what. And then that's the last part of the process, pretty much.
Yeah, this is pretty much the only part I ever see nowadays.
Yeah.
Here's the van. All right.
Literally delivering your stuff now. And that's the manufacturing part of the tour.
Cool.
Nice. So this is really the kind of the front end, the dirtiest end of the business. This is where we get the tooling that we need to do the job. This is where we keep the supplies like the mouse that you saw in there and cutters. And
it takes a whole other building.
It takes a whole other building. This is where components are received and kits are audited. Inventory is stored in some cases, metal housings and all sorts of stuff. Whatever supports production in the end comes here first. Initially gets audited and received, logged in, and then winds its way over to the other side of the building as we release kits for production.
Cool.
And there's a little lunchroom back on the other side over there too.
What's that?
So there's a little lunchroom on the far side over there, and the other side.
The lunchroom. We got to see where these people eat lunch.
Okay,
Okay, that's not that interesting.
Yeah.